Okay, so let's look at the following data set. Let's answer some questions. So one of the questions that might pop up is, let's find the mode. As we spoke, as I spoke in my previous videos, a mode would be the most frequent number, so the number that appears the most. In this case, we can see double 25. So we can then say, well, our mode is 25. Well, what about the mean? Well, the mean is going to be the average of the data set, which means I'm going to add all the values and I'm going to divide it by the frequency. Meaning, if I count these numbers, I can see there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. So let me type that in on a calculator. 17 plus 24 plus 25 plus 25 plus 27 plus 32 plus 58. Okay, so we have 221, and I'm going to divide that by 8. So that gives me 221 divided by 8, which is 27.625. 27.625. So this would be the average. Let's look at the next question. Well, the next question would be to find the median. So the median is essentially the middle number. We can do that by crossing out from left to right. And we see we're left with two middle numbers. So we can then take the average of the two middle numbers. So that's going to be 25. Right? Now the median is also equal to quartile 2, which is one way of grouping data. So therefore we can say, well, Q2 is then in fact also 25. So how do we find Q1 and Q3 then? Well, Q1 would be the middle value of the left side of quartile 2, and Q3 would be the middle value or the median on the right side of quartile 2. So let's do this. Cancel out. We're left with 17 and 24. Now we can do the exact same thing. We can say 17 plus 24, and we can divide that by 2. So let's see. Plus 24. That gives me 41 divided by 2, which is 20.5. So we have quartile 1, which is equal to 20.5. What about quartile 3? Well, it's going to be the exact same situation. We have 27 plus 32 divided by 2. That gives me 29.5. Okay, so what exactly can I do with these values? Well, first things first, let's find the interquartile range. So you can use the interquartile range to determine if there's any outliers on your data set. So essentially some value that does not belong there, right? You can think about it that way. So to find the interquartile range, it's going to be Q3 minus Q1, which is then going to be 29.5 minus 20.5. That gives me 9. So now to determine if there's any outliers, we can say, well, Q1, we're going to subtract this from 1.5 multiply the interquartile range. So let's do it. So let's say Q1 is what? 20.5 subtract 1.5 times 9, which is 7. So any values below 7 would be considered an outlier. Let's look at quartile 3. So for quartile 3, we're going to have addition now to find any outliers. So it's going to be then 1.5 times the interquartile range. So quartile 3 we said is 29.5. So 29.5 plus 1.5 times 9. So any value above 43 would be considered an outlier. And any values below 7 would also be considered an outlier. Now let's go look at our data set. Do we have any values below 70 or 7 that seems out of the ordinary? No. We have 13. Well, if we look at our first data set, we have 58. 58 is clearly bigger than 43, right? So we can then assign 58 as an outlier. Let's draw a box and whisker plot. First, I'm going to, that one's a bit, going to draw, so 10, 20, 30, 40, 50, 60. So let's do 10, 20, 30, 40, 50, 60. Now essentially what you want to do here is you want to find your minimum value. Okay, so the minimum value of this data set is 13. You want to find your maximum value. In this case, 58 is considered an outlier. So my next maximum value is going to be 32. Okay, you don't want to end your range at an outlier. Then you need quartile 1, which is given to as, or that we calculated, which is 20.5, 20.5. Then we have quartile 2, which was 25. And then we have quartile 3, which was 29.5. Let's identify our outliers. Our outlier was 58, since it was greater than our quartile plus 1.5 times the interquartile range. So it would look something like this. Q sub x plus minus 1.5 times IQR. Okay, this is to find outliers. So now that we have all these values, we can actually start drawing our plot. Okay. So how do we do this? Well, we're going to look for quartile 1 value. Let's go find the quartile 1 value in this data set or on this number line. So 20.5 is somewhere about here. So you want to draw like this straight line. Okay, 20.5. Then you want to go look. So you want to first do quartile 1 and then quartile 3. So quartile 3 is 29. So 29 is about here. No. Oh, I should have used lower values. And then you want to connect these 2 points. Next, you want to go find quartile 2, which is the median. So it would be somewhere in here. Then we can say, well, this is Q3. This is Q1. This one is Q2. Then you want to go look for your minimum value. Your minimum value will be 13. And you want to find your maximum value, which was 32. Oh man, mine looks so awful. Then you want to connect the 2 dots or the 2 lines. Now our outlier was 58. So 58, you want to go just make a little dot. Okay? And this would be our outlier. And an outlier in essence is, let's say you're given some data set and they all share similarity and you have this one outrageous point. That's usually one way to logically find outliers. So what else can we do? Now we can do a stem and leaf plot. Okay. So how do we do a stem and leaf plot? Well, I'm going to move it down. So I just need to rewrite this data set quick. Seven, 32, 58. Okay. So for a stem and leaf plot, it's very easy. You want to have your stem values and you want to have your leaf values. So this is one way to assign data or to arrange data. So essentially what happens on the left side in your stem column is you have your 10 values. Okay, you have your 10 values. So 10, 20, 30, 40, 50, 60, 70, 80. On your leaf values, you have your 1 values. So essentially it looks something like this. While your first column or your first row is going to be tens. You do have 10, right? So we have 13 and 17. This falls in the 10 category. So you have tens. And then for your leaf, you just want to put a 3 and a 7. This means if I rewrite my data, I can write this as there's 113 and there's 117. Okay, look. And then it gives you drum, drum. Okay, so let's look at our 2s. We have 20s, in fact. We have 24. We have 5. We have 5. And we have 7. So that's done. This is done. This is done. This is done. This is done. We used, and this one, excuse me. We used 6 values in total so far. So let's see. We have 1, 2, 3, 4, 5, 6. So your leaf column should always, or your leaf rows should always add up to the amount of values you used out of your data set. Right, so let's look at 3. So 3, we have 32. We don't have 4. And then for the next one, we have 50, which has 8. And this is an easy way to construct a stem and leaf plot. Okay. So these are some of the statistics fundamentals you need for high school. Other than that, yeah, becomes the only thing we need to really be careful for is the ethical use of statistics and not to manipulate it, right? Because manipulation of statistics in some cases could be considered a criminal offense, which is obviously not what you want. So just make sure to do research, look at the sample size before you trust the survey's response. Look at the population size, the amount of people that were asked. If it's less than 300 in some cases or less than 3,000, be very wary. Anyway, have a good one.